Buenos dias, bon dia, good morning to everyone. My name is Lee Ullman, and I run the MIT Sloan Latin America office, which is part of Sloan Global Programs. It's a real pleasure to be here this morning with Abel Sanchez, who's going to speak to us about computational thinking. My relationship with Abel started a couple of years back when we were working with Professor John Williams. We had brought John down to Latin America to speak about fintech. And John said to me, "Do you know Abel Sanchez?" I said, "Nope, I don't know him." He's like, "You have to know Abel. Abel really has been doing a great deal in Latin America, in Mexico, to bring MIT closer to the region." And so I had the pleasure to speak with Abel after John was down in Latin America and learned about all the wonderful things that Abel was doing. And since then, the beautiful patterns program that you're going to learn about today, we were able to bring it down to Chile one year. And so Abel is really a great supporter of Latin America, of bringing MIT ideas down to the region. And more than that, just a wonderful person. So other than a huge introduction, I just wanted to let you all know a little bit about Dr. Abel Sanchez, who holds a PhD from MIT. He's the executive director of MIT's Geospatial Data Center, the architect of the Internet of Things Global Network, and architect of data analytics platforms for SAP, Ford, Johnson & Johnson, Accenture, and many other Fortune 500 companies. So in the talk that he's going to give today, we'd like to make this as interactive as possible. So please feel free to use on the bottom of your screen both the chat, the raise the hand, and question and answer. If you're a Spanish speaker and you'd like to ask in both English or Spanish, we're happy to translate, so don't feel shy. Please put in the chat or in the Q&A in either language or in Portuguese. Not a problem at all. But without further ado, I'm going to turn over the webinar to Abel. And I'd just like to thank Jacqueline Taylor from Global Programs and Global Programs for helping us set this talk up today. So Abel, welcome and thank you for your time.
Hello, everyone. Good afternoon, good evening, and as I know, this will be played later, other times of the day as well. Thank you very much for the invitation. It's an honor to be with you here today. And I want to talk to you about a project that's near and dear to my heart, and that is teaching of computation, and especially to a group whose numbers haven't changed very much. Now, before we get going, a few administrative things. Just as was mentioned before, we are remote. I know I am competing against Facebook, email, many other things that are going on in your life. This is the nature of distributed engagement presentation. And so feel free to, say hello in the chat. In fact, why don't you do so now, just to hear where you're coming in from. It's not a very big group. I mean, we have 40 odd, but still, if you can say, what country you're coming in from, what city you're coming in from, it'll give us all a sense of, what type of participation and presence we have here. We see there that Christina from Venezuela, hello, Colombia. We have one from Mexico. Hey, there's Jorge. How you doing, Jorge? Nice to see you. Odd to see you here, but great to see you here. And by the way, a lot of credit to Jorge as well and the work that I will be sharing here today. And so with that in mind, let's go ahead and get started here with the presentation. I'll go ahead and share my email just in case you wanted to follow up on some of the things that we will be talking about. But overall, I'd like to tell you a story of this project, some of the insights that we've had now that we've been working on this for a few years. And once again, feel free to make any comments. I'm quite used to having the chat running, so it doesn't distract me. And if it becomes a little bit overwhelming, I'll just stop looking at it. But feel free to engage and participate. But as I mentioned, I wanted to share with you the story of this project, some of the motivations, some of the thinking that went into it, some of the insights that we have, new challenges that we are engaging on, and some opportunities that exist. So when it comes to the story starts out, or the genesis starts out, with a story that my mom's told me while I was growing up. You know, one of those stories that parents tend to tell you, right? And it was the following, right? That she had started university and she had taken a class and she had gotten the top score in the class, right, after an exam. And later being taken into the office and being asked to explain why, you know, how she had cheated, because it was not possible that a woman had outperformed all of the men in the class. Now, one of the odd things that exist is that, you know, a generation later, the representation of women, and this is something that I've talked about with women at MIT, women in Latin America, they're still very, very small, their presence, right? They are the only woman in their class, they're the only woman in their laboratory, and that really impacts the world in many ways, because we have huge challenges, as we've seen throughout the last year. And if only one, you know, half of the population is participating, this is not a good thing, right? So to give you a more concrete sense of what the numbers are, the numbers in the US 20 years ago were 20% were represented within the technology industry when it comes to computation, right? And today that number has actually gotten worse. It's a little bit below that. So instead of improving, we're getting worse. And what's more, when it comes to Latin America, those numbers are half. So only 10% when it comes to, you know, you can see here some of the countries, but really it's a number that goes beyond that. And if you look at the patterns that we see when it comes to the computer science majors, take a look at the groups there below the graphs, right? You have loads of groups, you know, white man, the ones that always get blamed for everything, right? They're at the top, you know, the biggest number. But if you look at all of the groups that you have here, white women, black men, black women, etc., take a look at where Hispanic women are, right? You are approaching zero. So if you look at, you know, the STEM field, it's already small. If you look at the participation of minorities, it's even smaller. If you look at the participation of Mexican women, for example, where this project starts out, you're approaching zero when it comes to, you know, the positions in Silicon Valley and so on. And what's more, those numbers are getting smaller. So as you can see, they're moving into 2000. Those numbers were trending in the right direction. But as you can see there, we've had a pretty big dip in those numbers. And although some of it has recovered, if you take a look at the number of Hispanic women, again, you know, this Latin American audience, you can see that those numbers are getting smaller. So that is definitely not something we want. And what's worse, for those of you who are not familiar with the history, is that the first programmers that existed ever in history were all women. If you read some of the history going back to the first computer that sort of set the template for all of the ones that were to follow in New Jersey and Princeton, you know, the Von Neumann architecture, all of that generation of programmers were all women. You can see here some of the pictures of the era. Now, what's worse is that when it comes to this new field of computational thinking, and I will define it here as the ability to be able to pose a problem from life in terms of computation, going through this decomposition, recognizing patterns, being able to do the necessary abstractions and matching some algorithmic design to it. This is becoming central to being able to do our work. And without it, we're really at a pretty big disadvantage. In fact, Rafael Rice, our president here at MIT, has stated that now all students need to be bilingual, meaning that in order to carry out your work, whatever else you might be specializing on, you might be a doctor, a biologist, a mechanical engineer, a business person, etc. In addition to that, you need to be able to think computationally. Why? Because the way strategy is implemented today is using technology. the way products are delivered are using computation. The way you understand your customers is using computation. The world is transforming. And we saw, pretty big evidence of a lot of that tooling within the last year as we all worked from home. So as I thought about this challenge and this problem and this lack of representation, I thought about, a course that I run at MIT. A pretty traditional course, a successful course in applied computation that a lot of people take. And I got one of those ideas, right? The crazy type of ideas that we like to do. The experiment that we really don't think much of, in the sense that, hey, let's try something here. Let's see if we can get something to work. I thought about the possibility of taking the same course that I teach at MIT, and teach it to women in Latin America, in this case, specifically in Mexico to start with, and to try to share with them our enthusiasm, our love for the material before they made decisions for college, to try to show them this beautiful world of potential and possibilities, right? Now, as I shared this idea with my wife, who is an educator, who is, very successful Harvard graduate, who has spent her lifetime in the world of education, an educator. She told me, she had a pretty negative reaction. She said, if you think what you do at MIT in any way prepares you to try to teach young women computation, you're out of your mind. Now, in the long tradition of husbands not listening to their wives, I went ahead anyway, right? And I reached out to an institution that I had collaborated with in the past, which is the Instituto Tecnológico de Monterrey in Mexico, as some of you might know, obviously the ones in Mexico. This is the largest university system, and they were incredibly supportive. They said, of course, Abel, let's give it a try. Let's see how it goes. I shared with them the materials that I had for my class, the materials that I had used internally to share a description of the course, and that had tremendous traction. People loved it. Everybody was excited by it. And so I shared those with them, and I thought, oh, they're set. All they need to do is get the word out, and we should get a pretty good response. And so we agreed to meet a month later. This was distributed, this was shared, it was posted. And then when we met again a month later, they told me, you know what, Abel, we really tried. However, we couldn't get a single person, a single young woman to sign up. And so I was pretty discouraged, and I thought, well, maybe this is a bad idea. Maybe my wife is right. Maybe this doesn't make any sense. But I told them, let me do an iteration and work with the women in my lab, some of my research assistants, and let's see if we can come up with something that perhaps can describe it in, and I can see there that somebody's commenting that this feels like a familiar problem. And we thought, well, let's see, how can we share these ideas that we really spend our lives on, that we dedicate our professions to, that we spend 5 years of doing PhDs focused on this problem? Can we describe it? Can we share it? Can we give people some of the insight into that magic, if you would, that we see all the time? And so we came back, and instead of calling, I had called the course Algorithmic Thinking, we came back and we called it Beautiful Patterns. And so that's where the name of the title of this presentation comes from. And we introduced a set of problems that looked like the following. So the very first one was how to find a boyfriend, how to keep a secret, how to pack a bag, how to plan a trip. And if you think we were trying to talk down to our audience, and you're not familiar with this, you'd be surprised. These are classic problems that we deal with in our field. So for example, how to find a boyfriend, it's a variation of the stable marriage problem that won a Nobel Prize in the 90s, recognizing it as such an important problem and a contribution that could be made by the persons that proposed an algorithm. How to keep a secret is cryptography, right? How to pack a bag is a classic optimization problem that freshmen all over the world are taught when they study computer science. How to plan a trip is a classic traveling salesman problem that is at the heart of many businesses, logistics systems, and really one of the most pervasive problems that we see. Now, having made those changes, explaining the material in this different way made a tremendous difference. We went from not a single person showing up to selling out the course. And in fact, although I had never shared my phone number, this is the phone number of my office, parents were reaching out to me and leaving messages in my voicemail and asking me if please they could find the spot for their daughter in this new course. And so we were filled with enthusiasm. You know, we started preparing, we had set a date, we were going to go out in summer. And so we bought tickets, we flew out. This was our very first time that we tried this, right? So it was a small team, you know, of about 6 women, myself, and we flew out. Now, as I was getting, you know, as we were approaching the city of Monterrey, Mexico, where we ran this first pilot, a lot of the doubts about what we had done started to creep back in. And I remember that first weekend before we started this workshop, thinking, you know, had we tricked people into showing up for this course? This is, in the end, you know, mathematics. This is not necessarily something that, you know, people get that excited about. The format of the course was really packing, you know, a semester-long course or a semester-long set of ideas into 1 week. And we were going to run 8 hours a day from 9 a.m. till 5 p.m. And so we started thinking, this could go pretty badly. This could be pretty wrong. You know, I don't think, you know, we had loads of doubts, and, you know, we were pretty concerned that Sunday night leading up to the Monday morning. You know, even that morning, Monday morning, as I was walking into the building, I was a bit apprehensive as to what was going to happen. Now, one of the things that I think continues to surprise me up until this day is the response that we saw. I have never in my career before or hence seen the type of engagement, enthusiasm, passion for learning, just willingness to participate and truly connect with these ideas that I saw that day. Throughout the lifetime of this project, this has continued to be the case. The enthusiasm has never waned. We have continued to see this level of participation. And I'd like to show you here a short video. So let me stop sharing these slides and open up my folder here where I can start the video. And let me make sure I have the right one. And I will select it now from my, that's the one thing that I wish, oh, and I of course forgot to share the audio, but that's one of the things that I wish Zoom did better. I fast switched to video. So let me go ahead and select that. Going to go ahead and share the sound, optimize it for video, select that, share, and I'll go ahead and play it here.
And so with that, I want to share with you some of what we saw in the classroom. We would look at every topic in 5 different ways: a lecture, an exercise, an application of their own choosing, a presentation on the topic, and finally a game to blow off some steam. What you're seeing here are the groups creating binary clocks. Now, I've seen a lot of binary clocks during my time, and I can tell you that their uniqueness, their expressivity, their design elements were refreshing and truly fantastic. Now, as I mentioned at the end of the topic, we would usually have some game. In this case, they're doing binary searches to try to identify something they're looking for and really having some fun. On the topic of cybersecurity, after covering security fundamentals, we set aside to do competitions on ciphers. Encryption is one of those things that can be challenging. However, we posed it in a way in where they could enjoy it and compete against each other. As you can see there, they're moving through the algorithms and trying to compete against their peers. Now, this turned out to be something that was pretty exciting, and all the groups really got into it. One of the algorithms they enjoyed the most was the Gale-Shapley algorithm, and they started off by trying to maximize the happiness of a dating pool represented by cards. They quickly moved from desk to floor as the combinatorial explosion took place. Now, once they learned the algorithm and mastered it, they started to apply it to problems from their own life, and they took just the same amount of creativity and enjoyment that they had in all the other topics. They made applications to sports, admissions, and orphanage to try to maximize the matching between parents and orphans. On the topic of complexity and growth, we took a look at the towers of Hanoi, where every new ring represents exponential growth. It was also a fun thing to try where students could compete against each other on their mastery of the rings. The topic of blockchain is one that can prove challenging even for adults in university. However, once they got through the fundamentals, the girls really connected with the core components, the disintermediation, the ability to have an absence of trust, the ability to have multiple writers, the ability to have a distributed database. And you can see here the wonderful applications that they did. In this last one, they're selling homes online. Throughout the week, they worked on a project that they presented.
Well, let me go ahead and stop it there and go back to my slides. And I'll say, the one thing that I'll say is that we came back, and even at the end of every of those days, we couldn't believe it. You know, that first day, that Monday, when we were so concerned going in, and then we saw what took place during the day, we would just sit, we just said, we're pretty tired too after teaching 8 hours, right? We would sit there and simply stare at each other in disbelief of what we had seen, right? The type of passion, the type of participation, the engagement on topics that we wouldn't think that they'd be excited about. So it turned out to be a great experience. As you might imagine, we came back to MIT. We understood that we needed to share this with a much broader group. We started to get participation from some of the local universities, so Harvard, Wellesley, some of the ones that heard about it from across the country, like Stanford, started to participate as well. There was a great response as well, and this is just a sampling. The numbers were much bigger. There was a great response from Mexican universities as well, and you can see here some of that type of, some of the young women that participated. A lot of friendships and learning, you know, between the different schools, the different groups that were participating. Even we ran experiments such as the Draw the Scientist experiment. If you haven't heard of it, is you ask a person to draw a scientist, and as you might expect, this is what they draw, right? And somebody with a lab coat with bad hair tends to be the case. I don't know why they have to have bad hair, but typically that is the case. And you can see we did that at the beginning of the workshop, and by the end, they were drawing pictures like this, which was quite a nice thing to see. And just responding to the question that was posted in the chat there about the age group, we looked at 13 through 17 years old. And that's actually a great question because we split the workshops into every day of the workshop into 2 parts. The morning was what I was calling algorithmic thinking, but that was the place in where you saw them sitting around a classroom doing activities without computers. Remember, they had those big playing cards, or they were just sketching on the board. And by the way, we never told them to sketch on the board. This is one of the things that surprised me. Of their own volition, they all asked for markers. They started to conceptualize that idea into a diagram that they drew on the board. The teams would participate and they would hand off. The collaboration, by the way, was off the charts. There were really no passive members in groups. And so all around, it was just something fantastic. Now, this project has grown significantly. We had 100x growth in the following 2 years to that first pilot. You can see there that we had 2,000 plus students going across the country. We had 300 plus instructors. You can see there the level of participation from many different cities in Mexico. And by the way, the logistics on this, anybody that's ever tried to organize anything big can imagine what it is. Credit where credit is due. The women at MIT were amazing. They were coordinating with everybody. Imagine just coordinating the flights for something like this. And remember, this is into Mexico. One of my biggest concerns was the concern of security. That was by far my biggest concern. I'm happy to report that we were able to move those big groups. The hosts were amazing. They picked them up at the airport. They would drive them anywhere they needed to be. They were fantastic hosts. If you saw the pictures from the group, you'd see them. They were all smiling, happy. It was a great experience all around. And see here some of the hosts. As you can imagine, this doesn't come cheaply. If you quantify the time, everybody was volunteering, of course, but if you quantify the facilities, the time, the airplanes, just the food that the girls were eating, you would come up with a number like this. All of this was handled locally. There were great people like Jorge, who I greeted when he joined on the chat, who helped us promote, to help us fundraise for this activity. And overall, it was just a fantastic project. The one thing that I'll say here at the end of this segment is that the women have started to be those simple, humble, fantastic girls have started to be an inspiration now to the rest of the world, as I have started to share this story. It was run locally here on the networks. A lot of people have reached out throughout the world. It's really an inspirational type of story. Now, I'll share with you some insights. As I mentioned before, if you have any comments or questions, do so in the chat. Thank you for the congrats that a few people have put. And I'll mention just some of the things that we saw or that we have seen throughout these last 2 years. One that perhaps if you're familiar with is not surprising is the growth mindset, that the majority of women have come in with this expectation. And by the way, one of the things that we have asked ourselves repeatedly is, why is the level of success and the level of engagement so high? And one of the reasons might be, and this is something that we have to dig further into, is that there's a lot of self-selection that happens, meaning that even as the numbers have grown, that level of engagement, passion has continued to exist. And it might be that the women that join the program are just self-selecting for those traits, right? Now, the other thing is that what we tend to see is what we call the growth mindset. That is that any type of failure you encounter, you see as something temporary. Because to be fair, these are ideas that can be overwhelming, right? That a lot of people feel like this picture, right? When you see blockchain, for example, I remember presenting to a group of the military and one of the generals saying, if you can get me to understand blockchain, I will truly believe you are a smart person. And this tends to be the attitude of many, and it can be overwhelming. But if your mindset is that it is something temporary, it is just a hurdle to overcome, it is something that everybody goes through, and that it is really just temporary. And that's a great point, the point of temporary. It is something that has a bigger impact in your success, academic success, than anything else you might consider. Now, interestingly enough, the other thing that we have seen is that most of the failures have to do with trying to do too much. And I make the comparison here to choreography because it's a pretty obvious one. If you try to do 100 steps, unless you have a photographic memory, that's a pretty difficult thing to do. However, if you ask me to do one step, even me, that I'm a terrible dancer, I would be able to do it. And so as you can see here, a lot of the messages that we have seen back is that most of it has to do with the attitude that you go into it. And what we teach in engineering and science, and that what people think of when they think about engineering and science, is that it's about suffering, right? You go to MIT, you're supposed to suffer. You're supposed to not sleep. You're supposed to have tremendous challenges, right? And the interesting thing, and here is, and this is something that took us some time to understand, is that getting the motivation right, it's actually much harder than the teaching. What I mean by that is that if you can get a motivated person to listen to you, then you're far down the line of them trying to and sticking with what you're trying to teach them than if you don't have the motivation, right? If you don't have the motivation, you see what you see in the MOOCs today, you know, the massive online courses, which have an attrition rate, meaning dropout rate, of over 90%. The courses that MIT offers to the world through MIT's open courseware learning that are free, that have grading and everything else, they get over 90% dropouts, right? But what we have discovered is that, and this is not a discovery, but what we have identified, many people know this already, is that if we can get the motivation right, then the complexity and the difficulty is less hard than trying to get the motivation right. And how do you get this motivation right, would be the question. And what we have found is that we share our passion. So every single woman that has gone out there is a woman that, just by the nature of them being at MIT, you know, this is a school that represents the top 5% of, you know, the academic system by definition, right? This is what is admitted, and it's widely recognized as having students that have great ability and great passion for technology. And so if you share that passion, if you share that interest, that turned out to be what we were doing. Remember, on our first attempt, nobody signed up, and later when we tried to describe it in a richer way, we were very successful. It turns out the passion is contagious. And when you believe it, when you live it, when you have that deep connection to it. For example, I as the program grew, I would spot check and walk into classrooms throughout different cities simply to see what was being taught. And I walked into this classroom in Guadalajara, and the person who was teaching, the woman that was teaching, was a PhD student, and her research was on worms, you know, worms, the kind that are in the earth that people use for fishing. And she was trying to study them to create neural networks that could be used for predictive learnings for driving. And after this program, she was going to go and start work at Uber, the company, in their autonomous driving program. Now imagine the access to a person like this in this type of program, and the opportunity that those young women have to hear, to listen to this perspective, to sort of peek into that world. And that is something that we found to be, again, contagious, right? That opportunity to see into this different world. And so that was, you know, in the end, you know, the Yates, the famous Yates quote comes to mind here, right? Where education is not about saturating a person, not about having them memorize things, but on the contrary, it's about lighting that spark, right? And that if you can do that, then the other parts are possible. Until you do that, really the rest doesn't matter. So anyway, this is where we are. Great quote by Jorge. And now I'll update you a little bit, as I mentioned on the agenda, about, you know, what has taken place since, right? The pandemic hit, and as you can imagine, everything stopped, right? The world moved online. This was a program that was heavily reliant on that face-to-face, right? Sitting in the classroom 8 hours a day, as was mentioned. And the world started to move online, right? Boot camps went online, because in many ways, this is very much like a boot camp. However, they were expensive, and for many good reasons, they were expensive. However, we started to do a program that had a lot of those elements, but that was free. And I'm happy to share that in the past year, we've had 3 generations of learners, which have all been online. And there's some great advantages. So for example, we had participants from Venezuela, from Argentina, from Chile, from other places as well. I think Colombia or Ecuador, I'm not sure which talking about the big groups, right, that were participating now. And in fact, this has opened up a new door. And we're now thinking about, if we can deliver a program online, can we deliver it to 1 million women? And this is the part where it becomes yet once again sort of a crazy idea. We're thinking of a scenario, and it has its challenges, and I'm happy to address any of those in the chat, but I don't want to go too deep into them because I've already run quite a bit. But we're thinking of automating fully. Admissions would be done through an algorithm. We would leverage natural language processing, voice, video, mass classifications, as you can imagine, through reporting like it's done on other platforms. We will move, instead of instructor grading, to peer grading. A lot of the research shows that that is just as effective and scalable as well. There's a lot of the participants in the group that come from the machine learning and AI disciplines. And so we will start monitoring the analytics to try to get that understanding that you would get if you were there in presence. We're looking at experiments, building community, a lot of different technologies that are being used. And then the most recent one, and one of the most important ones, is community generated content. Creating a course such as the one I have been sharing is something that requires a lot of effort. And as mentioned, it was really a spin-off of a course that I had created over the past 10 years at MIT. And so creating new courses can't really have that level of investment because it takes too much effort. And so we have started an effort, and when I say we have started, we have already generated one course this way, that is taking an open source approach, just in the same way that people create software in a distributed manner throughout the entire world and contribute to this new product that then is the backbone of some of the largest companies today. So if you look at Facebook, at Amazon, at Google, they all run on open source. This code basis that people throughout the world, again, contribute to, and that are not paid for, and that the software itself has no licensing and is free to use. We're taking the same approach when it comes to creating courses. And this is the part that I mentioned about the invitation, the opportunity to contribute. And what we're looking for primarily is somebody to contribute lessons. And this is women authors, right? And to be more concrete, because this can be a bit broad, we're really looking for people to contribute 1 hour of content. And that comes down to about 6 lessons, right? If you're doing 10 minutes, but it's really not about the hour or the 6. It's more about being able to communicate the idea in a way that is effective. And so you can see here that, this could be 6 videos of 5 minutes, or it could be 6 videos of 10 minutes. You could also do it with a colleague, which means you would only do 3. But ultimately, that week of content, because it turns out to be 1 week of content, and oftentimes the material that is created, the 1 week really spans 2 weeks when it comes to running the course. It's really a great building block, because if we can get 3 of these, 3 hours, that's enough to be able to create a course. And so, if you're interested in participating, please reach out. If you know people who might be interested, please share the materials. And the other thing that I would share is that you can contribute in other ways. Much like when it comes to open source, a part of open source is education, meaning teaching others on how to contribute to open source. Part of it is documentation, that is writing. Part of it is marketing and communicating, making this project visible. And so there's other ways to contribute. And for a motivational aspect to this, you'd be joining an international team, throughout Latin America and the US. And as mentioned before, our goal is to be able to share this with the world, right? So all of the content that we would produce, all of these courses, would be freely available to anybody that wants to use them. And our hope really is that as they start to be used, much like it is in the case of open source, we would get some of those contributions back about, say, improving an exercise or improving a certain lecture, or even creating a new course. So join us. You can learn more about this project, dreamers at MIT.edu. And now I'm happy to take questions. I know that there was a few comments there. One person asked about, I think he was Egon, about the opportunity of being able to share it with her daughters. We're right now, the current cohort has already started. It started 2 weeks ago. But if you write to me, I'll happily share or forward your email to the group that is handling admissions. And they can apply for the next cohort, which will run, since we just started, it will run again in 2 months.
Hey, Abel.
Yes.
Just two things. That was a question here. And I think for those who don't know about the program, the students that went down in the past and the students teaching the courses, as well as Abel, it's done in Spanish. That's
Yes.
one of the unique things about this program. Yes. And when we did it in Chile, although there are not that many faculty at MIT who speak Spanish, Abel is one of them. And there are a lot of students who actually speak Spanish. So recruiting students who can go down and both teach and interact in Spanish is a great part of this program, because obviously many of the communities that Abel and the Beautiful Patterns works with are not people who are fluent or able to or have a good command of English. So that's one of these great things about this program, and one of the things I love about it.
Thank you, Lee, very much for that. I didn't mention it, but that's what we're most in need of, native Spanish speakers, because there's a lot of people who speak Spanish here at MIT, but that's different than being a native Spanish speaker, right? And there's a great saying in English that says, what do you mean you don't speak Spanish? What are you, not American, right? Because there's so many people that speak Spanish, but speaking like a native Chilean or Mexican or any of these countries is different, right? And so we've tried to modularize the contributions down to, as I mentioned, 1 hour of content that you could contribute, and we found that that's a manageable amount. The people who participate usually take about a month, right? You spend some time preparing. Hopefully, you pick something that you already quite familiar with. And then it takes you about I'd say doing one recording per week is not too demanding on time. That would be, say, doing 10 minutes a week. If you've never ever done it before, it sounds like you could shoot it all this afternoon. It turns out that doing 10 minutes a week is about the right amount, because you think about it, you try it, make a mistake, you want to do it again, etc. So it's not too much, and at the same time you can make a contribution. Obviously, if you want to do more, that would be great, but we found that 1 hour block of content tends to be a pretty good chunk. I see there's some comments. Let me see, I'll read it out loud from Christina. It says, I'm a high school senior and I want to set up a hub for computation and music composition in Venezuela as a career path. And by the way, we had a terrible experience with Venezuela, no fault of Venezuela itself, but the servers that we started to run on here in the US, they had restrictions because of US State Department that would not allow us to serve to Venezuela. Everywhere else in Latin America was fine, but to Venezuela we couldn't. And so we're looking at how we can address that issue. But this is an issue that we're dealing with at the moment. Maybe we can just bounce through Mexico and then that would be okay. But anyway, that's just sort of an anecdote. Let me take a look at some of the other comments.
Abel, one of the questions I think that's important that just came up from Patricia. It says, very interesting. I understand, about the time, but it's not clear to me what the profile of the person that this could help. And so, again, I'll let you answer, but in the experience that we had running the program in Chile, it helps everybody. I think the future and the way one needs to think has drastically changed. And it's pretty impressive when you start to get young students, whether high school, to switch the way they go about actually addressing issues or problems, whether it's math, but it's more about changing the way someone thinks and not just programming. And that's what I found so interesting and I think so rewarding about the program itself, but I'll leave it to you.
No, that's a great point. when I speak and I do a lesson, there's a lot of barriers to getting access to what I'm speaking, because in some ways I speak a pretty specialized vocabulary, right? It's something that you sort of can't avoid after some time. When somebody who doesn't have that context explains material, they're actually much more effective because they use what everybody else would understand. And so it's actually better to have a non-expert, assuming they get to the point where they can explain it well, right? To have a non-expert explain a concept. Now, what has been our usual profile has been the engineering and science, but note that I'm not saying computer science, right? So we do have some computer scientists, as you might expect, but perhaps one of the most successful instructors came from earth and atmospheric sciences, which you don't think of as being somebody who would do a lesson on computation, right? And she's done one of the most exciting ones that I've ever seen. She was teaching loops with counting teeth in your mouth, which I know it doesn't sound like it makes sense, but it was a captivating lesson that really explained. And that's another thing that I should mention as well. Making those mappings, our knowledge ultimately rests on the physical world, and making those mappings and analogies onto the physical world is what carries or what gives access to that concept, right? Now, there have been people that have come in from the business school and have been able to teach this as well. So if you're, I would say, if you want to think, take a step back and see if you can contribute one. If there's some topic that you're interested in, for example, learning about distributed software creation, like something with the GitHub platform where a lot of people contribute to in an open source manner, that might be a topic that you would want to address, right? You'd spend maybe 2-3 weeks learning about it, and then get to the point where you say, okay, I can do 4 or 5 10-minute lessons, 5-minute lessons, depending. Some topics require less, some topics require more, right? In the case of GitHub, I could see how you could make 3 lessons that are under 5 minutes that would explain the basics. And what we're trying to get to is the basics, the fundamentals. We're not trying to create experts. Now, there will be some of that later, and there's already some conversations about it. And the other thing as well is not every single topic in computation is technical from the sense of writing code. We're in the middle, for example, of creating one that is design thinking. When you think about creating software, there's a lot that goes into it that is not writing code. And so when you think about the design cycle in its entirety, it's a much broader problem and a much richer problem. Psychology comes into play, a lot of user experience comes into play, design sensibility from a graphics perspective comes into play. Again, all of it beyond the code itself. And so what I mean to say by this is that we're really looking for a broad set of expertise, and ultimately we want to make this a lot more accessible to many more people, and not just the coding itself, although the coding itself, of course, is part of it, right? Does that answer your question, Patricia, or not? Great.
Hey, Abel, I think another question that seems to be throughout the chat and the Q&A is how can people get involved, whether in Mexico, Colombia, Argentina? People are really curious, how can they either themselves be involved or have their students? We have several educators across different groups. And Leilani is someone who we've worked with. She was at the Edgerton Center. She worked with us in Chile, and she was also has MIT helped. And at least what I know MIT has helped a great deal with connections for you to make this happen, and tries as best as they can across the institute, at least what I saw.
No, that's right. This is a project. It's one of those that everywhere we go, doors open for it. But when it comes to the mechanics, let's say, how do you get involved, right? The very first thing to do would be to reach out to me, send me an email. I can direct traffic to the right groups. When it comes to the actual participation, let's say you wanted to contribute a topic, right? So let's see where it is. Here it is, right? Let's say, again, just to take an example, you wanted to contribute GitHub, right? There turns out to be active repositories where we are creating these lessons in a distributed fashion. Think of it as a Google document that we're all participating in, right? We nowadays, there's a presentation or there's some document and we all come in and we add a paragraph and we divide it up into topics and we might do some edits. All of it is a group. We're doing something equivalent, but we're doing it with courses. And we're using a platform called GitHub because it facilitates this process. What we do is we start off with a document. That document then gets translated into people who are responsible for sections. Those people then go out and create the videos, take the GitHub lesson, for example, and you might have one there, how to create a repository, how do you share this repository, how do you take a pull request? It doesn't matter what that is, it's just something part of it, right? Then each of those that had those assignments go out and create those videos. And then you have some mechanisms within this platform to be able to provide feedback. You can do a few cycles. And the huge advantage, and this cannot be overstated, is that nobody has to go to an office. We rarely meet beyond synchronization and answering questions. And it's not that we avoid the meeting, is that we don't want to get the whole group together because it's too expensive. One-on-one meetings are happening all the time. But this process is carried out that way. So coming back to perhaps the simplest possible way, you're doing GitHub, you're on your machine, you have PowerPoint up, and you have your slides that you're going to go through. You can capture your screen, you can do your 5-minute videos, you upload them, we'll share with you where you can upload them to, then you link them into that document completes, there's a number of iterations that happen, and that course can now be shared and with the world, right? That is the process. So it comes down really to just recording on your screen, making those lessons. If you're writing code, then sharing your code editor while you're writing it. Typically, you would have some sort of slides. We have a lot more structure, and I'm happy. For anybody that's interested, I'm happy to do an additional meeting where I can go over the steps and share with you some of the ones that we have already done it. It's one of those things that it's easier to show than it is to explain without the artifacts that we would be using. So hopefully that's easier. That illustrates some of what we're doing. If not, as I mentioned, I'm happy to do a follow-up where we just talk about the authoring process. And if you're interested in writing or doing translations, especially as we start to go to other languages, for example, Portuguese, you can contribute that as well.
Bill, just a question that I have. So I really liked your slide about getting to 1 million. And one would think, that's really crazy, but I remember when you first started the program, I think it was with like 40 students. And then by the time I got involved, you were already in the thousands of students. So it actually grew much quicker than you imagined. So I know many people see this and say, wow, that's super aspirational, very MIT, but I think it's realistic in terms of the growth pre-COVID that you were having. So maybe you could speak a little bit about that, because other than, people saying, wow, those crazy MIT folk with their big numbers, I do think it's realistic. It's not so far off based on the growth that we've seen at MIT with MIT edX and other programs that are happening.
Yeah, thanks, Lee, for that question. In many ways, this came as a reaction to what we saw during the year of the pandemic, right? There was tremendous amounts of interest. And as I mentioned, we had 3 generations go through the online program. However, we couldn't scale to meet the demand, right? Because having live instructors is expensive and limited to the number of people you can pay pay attention to, right? And so the thought process was, how could we scale to say 1 million in a way that was realistic? And it turns out that if we go to that number, the resources, given what, I'll share again, I went through it pretty quickly, turn out to be very reasonable, meaning not beyond what our expense is now. Part of the problem when it comes to doing the online admissions has to do, we have underage women who we need to be very careful who we admit into these online programs, right? I think we all understand what the risk could be here. So we actually had everybody apply by creating a video. And so somebody had to scan, over 1,000 videos, right? That were saying, I would like to participate. And you can imagine that that doesn't work, right? Now, all of us, because of where we live and what we do, know that identifying gender, identifying intent, and identifying, and we're also making decisions based on passion for the material, because not everybody could be admitted, right? Now, we know that we can identify all those things using artificial intelligence, right? Will we miss here and there? We will, but this is what we were talking about, misclassification, doing through student reporting. When it comes to grading and other constraint, there's great publications, happy to share with those educators that might be interested in, that show that peer grading is just as effective than grading by a professor, which means that we can start to do peer-to-peer grading, and that would facilitate as well in building community. One of the things that we're pretty happy of is that we've been able to create community online, which is not a simple thing to do. We had, again, if anybody's interested, I can share some of this. The participation was, we on Slack, the free version of Slack, if you've ever used it, know that there's a 10,000 messages limit. And we had the 10,000 messages limit within 2 days when we were actively running the workshop. So we've been able to do that pretty well. We have been able to connect the population that's out there. Now, in addition to that, there's a lot more that we are planning at the moment when it comes to doing student analytics. So what's taking place, being able to understand, for example, attrition. When do people want to leave the course? When can we do an intervention? All things, and by the way, for those of you who do not know, I am pretty active in MIT's education online programs. So I'm pretty well connected to what's happening to this by the most forward-looking companies at the moment right now. And so a lot of those learnings are coming back into this program, right? Now, ultimately, when we go purely online and this scalable hundreds of thousands, millions type of number, the community has to grow equally. And this is something, again, that we have been working with already. There's a pretty good ecosystem there. And an additional added benefit of this is that as people start to distinguish themselves, and there's a bit of a power law distribution here when it comes to the participation of the communities, you start to get standouts. For example, there's one young woman that probably did herself something like 30% of all the responses on the platform, right? And she's now widely recognized as somebody who's deep and knows her content well. And this is a wonderful thing to see. And then you start to have the community. And this is, again, just mirrors a lot of what you have in other communities on the web. And it's something that we're leveraging in as well. And then that last part had to do with the creation of many more courses when it comes to that last part that we talked about. But yes, the 1 million challenge, really the biggest challenge, Lee, would be marketing, making more people aware. Because right now, I would say, unofficially speaking, we probably reached, 20,000, maybe 50,000, right? And we probably have to reach 50 million, or I'm not sure exactly, I'm not a marketing person, right? But we have to reach 20 million to be able to get that million. But when I say reach, it means just them being aware of it, right? Because there's a flood of information today. How do you even get people to know this, right? So the resource is not the constraint. The constraint is simply the awareness of it, right? And given the way we are going about this, the more people, the better.
So I think the message for everyone is please share what you heard today. Please share this with your networks, get this out there. More than anything, I want to thank Abel for his time and more importantly, for bringing this to the world and to Latin America. It really is an amazing program. If you've never seen Abel's TED Talk about beautiful patterns, it's really inspirational. You saw part of it in the video, but it's really incredible what Abel has done, taking this project forward, both for women and for the region. So please stay safe. Thank you very much for being here. Please don't hesitate to contact myself or Abel. And hopefully we'll get to that million within a couple of years. It really is inspirational, and I think it really is making the impact that people are looking for. So thanks to everyone. Have a wonderful day and stay in touch. Bye-bye. Thanks, Abel.
Thank you very much for the invitation, Lee. Thank you all for listening. Take care, everyone.
Bye. Ciao, gracias.